Welcome to the lesson on voltage. In this lesson, we will look at the fundamental concept of voltage, explore how it is measured and its significance in battery electric vehicles, abbreviated as BEVs. Let us look at our lesson objectives. By the end of this lesson, you will be able to define voltage and explain its role in electrical circuits. Later, you will be able to identify the unit used to measure voltage. Next, you will be able to explain the different types of voltage levels in BEVs. Finally, you will be able to describe the relationship between current, voltage, and resistance in BEV circuits using Ohm's law. BEVs use electrical energy stored in batteries to power electric motors and various other components, requiring intricate electrical systems. Variations in voltage can signal problems such as failing components, poor connections, or other faults within the electrical system that need to be addressed to ensure proper functionality. High voltage systems, commonly found in BEVs, can be dangerous if not handled correctly, posing risks such as electric shock or fires. Proper safety measures and training are essential when working with high voltage systems. In this lesson, we will focus on the concept of voltage, the different levels of voltages in BEVs, and the relationship between current, voltage, and resistance using Ohm's law. Voltage is defined as the potential difference between 2 points of a conducting wire. Imagine you have a water hose connected to a faucet. The hose's water pressure represents the electrical circuit's potential voltage. When you turn on the faucet a little bit, the water flows out of the hose with low pressure. This low pressure can be compared to a low voltage in an electrical circuit. Imagine turning the faucet handle further, increasing the water pressure in the hose. The water now comes out with more force. This increase in water pressure resembles increasing the voltage in an electrical circuit. Likewise, when you increase the voltage in a circuit, the electrical energy flows with more force, allowing devices like motors to operate more effectively. So, just as increasing the water pressure in a hose makes the water flow with more force, increasing the voltage in an electrical circuit provides the necessary energy for electrical devices to function correctly. It is important to remember that voltage does not flow. It is the pressure that causes the electrons to flow, or the pressure that causes current. Voltage is the force that pushes electric charges through a circuit. Voltage is measured in volts using the V symbol. BEVs use multimeters and voltmeters to measure voltage accurately. In this image, the BEV is being charged and the voltage is 242 volts. Voltage represents work per unit charge, which measures the force that pushes electric charges through a circuit. Voltage could also be represented by the letter E, which stands for electromotive force. Voltage is critical as it determines the amount of electrical energy available to power the vehicle's components, including the motor and battery. The Code of Federal Regulations, abbreviated as CFR, is the official compilation and codification of the general and permanent rules and regulations published in the Federal Register by the executive departments and agencies of the federal government of the U.S. Within the Code of Federal Regulations, there may be specific sections or regulations that pertain to BEV high-voltage systems, particularly concerning safety, manufacturing standards, and operational requirements. The Federal Motor Vehicle Safety Standards, abbreviated as FMVSS, establish minimum performance requirements for various safety features in motor vehicles to protect drivers and passengers. The Code of Federal Regulations, Title 49, Federal Motor Vehicle Safety, Standard 571.305 defines high voltage in electric-powered vehicles as greater than 30 volts AC or 60 volts DC and having an outer covering with the orange color. S54.1.2 is part of the Federal Motor Vehicle Safety Standard, FMVSS, 305, specifically addressing electric-powered vehicles and their safety requirements related to electrolyte spillage and electrical shock protection. This regulation outlines various standards for electric vehicles, including the mandatory use of orange color for high-voltage cables that are not enclosed within electrical protection barriers. This color coding serves as a clear and immediate visual warning to individuals working on or around the vehicle. Now, let us look at different levels of voltages, namely low, intermediate, and high. A low voltage level is comparable to a tiny garden hose with low pressure. In direct current, it is around 30 volts, and in alternating current, about 15 volts, safe enough to touch accidentally like a gentle sprinkle. It is marked with root mean square, abbreviated as RMS, for effective voltage in AC circuits. Intermediate voltage is like a medium-sized lawn watering pipe with more pressure than low voltage. It ranges between 30 to 60 volts for DC or 15 to 30 volts for AC. Intermediate voltage level requires more caution. There is no universal color standard for the outer coverings for the intermediate voltage levels. General Motors has a blue outer covering for intermediate voltage levels. High voltage levels are like a big fire hose with a lot of pressure. It exceeds 60 volts for DC or 30 volts for AC. It is very dangerous. The coverings are identified with orange markings and require extreme caution. Now that we have discussed the different levels of voltages, remember that there isn't one single rule book for voltage levels in everything. However, companies often set their standards for different situations. Remember, to be safe, always confirm the color and the specific voltage of anything you are working with the manufacturer's guide. The relationship between voltage, current, and resistance in an electrical circuit is governed by Ohm's law, expressed by the formula V equals I times R. This law essentially states that the voltage across a conductor is directly proportional to the current flowing through it and inversely proportional to the resistance it offers. Let's say we have a simple circuit with a light bulb that has a resistance of 6 ohms. We can use Ohm's law V equals I times R to find the voltage across the light bulb. Volts equals 2 amps times 6 ohms. Volts equals 12 volts. Let us now recap what we have covered in this lesson on voltage. Voltage is the electrical pressure that pushes electrons through a circuit, resembles water pressure in a hose. Voltage fluctuations can signal potential problems within the vehicle's electrical system. Technicians must be able to measure and interpret voltage levels for accurate diagnosis and troubleshooting. Voltage is measured in volts with instruments like multimeters and oscilloscopes. There are 4 common voltage levels: DC high voltage, DC low voltage, AC high voltage, and AC low voltage. Ohm's law highlights how voltage is directly proportional to current and inversely proportional to resistance within a circuit. Understanding voltage is crucial prior to working on BEVs. Thank you.